The future is watching. Welcome to Opcode Virtual Summit.
Hello, 1 2 1 2, mic check. I hope everything is working well. And so we are back for a sixth edition of Opcode Live, and thanks for joining us. I can see already some names of people who have been here for the previous editions, so that's pretty cool. And as you may have guessed for today, the theme is going to be around privacy, but what resonates better with privacy than a cyberpunk dystopian theme, especially with what's going on now in the news. That's quite an interesting timing, as you can tell from the stock market indicator at the bottom. So the stock market in the US is booming. So a lot of contradicting messages in our current reality. And if you're in the US, I guess stay safe. So for today's edition, we're gonna have a pretty good schedule, but before we start, just let me remind some of the rules for everyone if this is your first time, for instance. So as you can see, there is the chat on the side. So if you have any questions while someone is speaking, or you feel free to interact with each other, just be respectful and just don't go over the top. Initially when we all started the stream is because we're all confined, and so it was mainly like to have like some entertainment where you can just like hang out with each other, even though like a lot of the conferences have been cancelled and are still cancelled. Except that the format for those who have attended Opcode in the past, instead of doing a once-a-year conference, the format here is every 2 weeks. This is edition number 6. The next edition is going to be in 2 more weeks, so on June 17, so same thing on a Wednesday, same time. The information will be on the website as usual. And if you want to speak, there is the call for paper link on the website. So you can just go here, and so you have the call for paper here. So if you want to participate, or if you want to recommend a speaker, which is something which happens a lot actually, from our attendees, feel free to just submit a name, just send me a message either in the chat here or over email or on Discord or even on Twitter. You're more than welcome to join also like the Discord chat. So when the conference is over, that's where we keep exchanging with each other. So the link is at the top, I guess, over there. And that's pretty much for the rules and the format. Also same thing. If you want to speak about something, but you're too lazy to make slides, but you already wrote a blog post, feel free to actually come over and speak with your blog post too. Some people prefer to present with slides. Some people prefer presenting a blog post. Which is also like something which is quite good too, actually, because some blog posts, like the one from our keynote speaker today, are usually like quite extensive and well written. So it's always good whenever there is like some reading you would like to do, but you don't have time to do. So let's review the agenda while we are all getting ready. So the first presentation is going to be from Yarden Shafir from CrowdStrike. She published a really series of a really good two-part article on the Windows Debugger and AutoScript with the data model, which is pretty cool. As far as I've seen since it had been released, this is the first extensive blog post I've seen on the topic, although it's a really powerful tool that is part of Windows Debugger, like a preview now. So really looking forward to it, and I think more people should be using that. And the next presentations is from about the Linux malware from Silvio and Antonio from Leonardo. That's gonna be also like pretty interesting. Yeah, they are OPCODE attendees. Were like, hey, like we have this cool thing to talk about. Would love to present it. So I said, of course, and like you will see, it's gonna be like pretty cool. And then we're gonna have a conversation with Joseph Menn, who is a quite well-known reporter. Has been in the industry for like, I would say 30 years. I guess he can correct me after, but that should be like quite interesting. And a lot of the stories in cybersecurity, usually his name is not too far, like the RSA story that happened like a few years back. And last but not least, we're gonna have Matt, who's gonna speak about Intel PT traces for vulnerability analysis. So that's also like pretty cool. Personally, that's I'm not very familiar with Intel PT, so that's something I'm really looking forward to watch, to learn more about it. I've seen a lot of people talking about it for the past like years, but I really don't know anything about it. So I'm really looking forward to learn more about it. Yeah, that's pretty much it for the introduction. I don't want to take too much of your time, as I also want to watch the presentations. It's basically become my meetup, where like every time I see some interesting stuff but I don't have time to read about it, I just tell people like, I just come over, like speak about it, you know. So I'm as excited as you to watch those presentations. Yeah, and that's pretty much it. So yeah, Yarden, you can get ready for sharing your screen, and I will launch the trailer.
The future is watching. Welcome to OPCODE Virtual Summit.
Done. Hi, can you hear me? Hi, I'm Yaden. I work at engineer doing research and dev. I previously worked at Sentinel-1, did a few roles there. And I'm a circus artist about half the time. And now we're going to talk about Windbag, WinDBG, Windybug, however you like pronouncing it. It's a very strong tool for debugging on Windows, but until a few years ago, was also a real pain to use. But a few years ago, why can't I move that? Up to a few years ago, Microsoft added the new debugger data model that you can access through the dx command. This data model gives us support of native objects through NatVis. These objects are defined in XML files. There's plenty of objects that are defined by default, and also you can go and define your own objects to use them. You can also interact with all of these objects through LINQ, which is an SQL-like language. You can query them with select, where, you can order them, and do lots of other stuff. The main thing we get from this DS is that we don't need to use MASM anymore. At the bottom of the slides, you can see a MASM command that lets us see the name for an object. The whole 2 lines is one command. It's horrible, and if anyone can read that or write that, then you get points from me, and I apologize that you ever had to learn that. So what we can do with this DX is first we get some new registers. We can define our own registers. For example, I define a register that I call my string. We can pick whatever name we want. That is the string. It can also be a number. It can also be of any type that that it knows about. Any type that's defined or in the XML, or as we'll see later, it can also be some dynamic types. But other than that, we also get some built-in registers that are very useful, like cur thread that shows us information about the current thread. Now, this is not directly the kernel thread. This is a container that contains some information that we thought might be useful for us. For example, the stack, the register state for this thread, and the kernel object that is actually the thread. We similarly have cur process, also has a fake name. Under IO, we have the handles, all the handles that this process has. Now you can see that this array is not indexed by 0, 1, 2, 3, whatever. It's indexed by the number of the handle itself, which will be useful. We'll see that later. We also have cur session. That the name might be confusing. This is not a kernel session. This is the debugger session. We have the debugger session here. That's the IP of the machine that I'm debugging. That's my key. Now you all know, and the port I use. And in this cur session, we have the array of all the processes in the system. And like with handles, this array is not indexed by 1, 2, 3, 4, by 0, 1, 2, 3, 4. It's indexed by the process ID. And for those of us who, which is probably all of us, who are used to seeing process IDs in decimal, we can do dx cur session.processes, comma, d. This shows us all the numbers in decimal. Now let's say we have a case where we want to find some information in the process explorer exe. In the old way, we had to run bank process 0, 0 explorer.exe, copy that address, which is the address for the eProcess, and do dt empty eProcess address. Now look at the eProcess. We can also search for something like image file name, and we see the file name for the process. That's a long and kind of annoying thing to do. With dx, we can do all of that in a very simple command, dx cur session. We have processes. Now, I said we can use link. Link lets us do where to filter out only the processes that match our requirements. So where gets a process, we'll call it P. An arrow, and we only want processes where p.name, because this is a container that gives us, among other things, the parsed name of the process, equals explorer.exe. This is going to return an array of all the processes that match that. In this case, we only have one, so we can do dot first and get the process itself. Now, what can we want to see in Explorer exe? For example, its signature level. That tells us how it's signed. It doesn't tell us who signed it, but it tells us which level it's in. If it's unsigned or signed by Microsoft or Windows Sign or whatever. Now we take our process and we go to its kernel object, which is the eProcess. And inside it, we find signature level. By the way, all dx commands are tab completed, which is awesome. So we printed our signature level, which in this case is 0. Now 0 doesn't mean I have some weird unsigned Explorer exe around the machine. 0 means unchecked, because signature level is only provided when needed. Not every new process is going to have a signature level automatically. 1 means unsigned, but 0 means unchecked. So now let's take a look at the signature level for all the processes in the system, which is a thing that would be really annoying to do. Without the X, you'd need to use for each, which I never personally liked. So again, we iterate over all the processes on the system, but now not with where, because we don't want to filter. We do select to only see the attributes that we want to see. So again, for each process, we want to see p.kernelObject.signature level. We see here like stuff like 3E, 3C, 1E, but we only actually care about the bottom nibble. The top nibble tells us stuff like where this is a PPL or a protected process or stuff that we don't really care about right now. So we take our command and we zero out top nibble, do an AND with 0xf. Now we have nicer stuff. But let's see that as decimal because it's easier to look at in decimal. And now we can see slightly more familiar numbers like 12, which means it's Windows signed, 14, it's TCB, a few more. We can order them too with order by if we want to. Now we see that process with ID 4852 is Windows signed, but we don't know very much about this process other than that. And yeah, we can go back to the process array and get this process and look it up, but we can also do something easier. We iterate over all the processes, but we only chose to get signature level for each. Instead, we can choose to get a few attributes. To do that, we need a new type that contains, for example, a name, a process ID, and a signature level. So we can go to the XML and define our new type, or we can use a dynamic type that is called an anonymous type that will only be used in the command where we define it. So the way to define an anonymous type is with new, curly brace, name of field equals value. We have a field called A that contains the letter A and a field called B containing the number 4. So now we have our new type that we defined in this command. So we can do something similar. We go back to our command where we iterated over all the processes, and instead of just getting the signature level, we define a new type with name equals p dot name, PID equals p dot ID, which is another attribute, and signature level is our signature level. But now we only see an array of processes. If we click on one of them, we do see our structure, our type. But if we want to see all of them at once, we need to add -R2. The -R tells us the level of recursion it's going to show us. The default is R1, which is only going to show the first level. So we're adding another level. And I can see all the processes and their signature level. And a wonderful thing that was added is grid view. We run with -G, and we get this beautiful table with process name, ID, and signature level. And these headings marked in blue are clickable, and they sort the table. Yeah, we click on names, and now we have names sorted alphabetically. The annoying part about sorting with the headings is that they remove the formatting. Yeah, now everything is back in hex. We can do order by manually, so we do get form. So this way we can see an attribute, a specific attribute for all the processes on the system. We can also do that for any iterable thing, all the threads, all the APCs, all the whatever it is that we want to look at. So this is one thing we can do with DX using the built-in registers. Another pretty useful change that this added was a change in breakpoints. There's a few things that were added for breakpoints. For example, a function to easily define a breakpoint over access to a variable, reading or writing from it, basically a slightly easier way to do BA, if anyone knows the command, and also a way to put a breakpoint over a source file. Now, if you have your C file and you want to put a breakpoint over that, there's a function to do that now. Again, it was possible before, but slightly obscure and not very well known. But the thing I found myself using the most is a change to conditional breakpoints. Now, again, conditional breakpoints were available before too, but they weren't very very convenient to use. But now we can do BP/W and run dx command. No need for dx here, but the command here will be our conditions. And then we can place our address. So let's say we have an issue with threads writing into files while the thread is impersonating a different process. So the way we'll write a conditional breakpoint for that is BP/W, and our dx command will be tab completion is annoying here, so we'll do it here first. We can see if a thread is impersonating by running cur_thread.kernel object to get to the thread. Search here for client security. And in client security, we have impersonation data, which tells us whether or not it's impersonating or not. Now, in this case, impersonation data is 0, which means the thread we're running right now is not impersonating. If this is anything but 0, this is an impersonating thread. So we'll take this command and do BP/W. Current thread impersonation data is not 0, and we'll place our breakpoint on empty write file, because in our hypothetical scenario, that's where the problem is. So place our breakpoints, keep running, and we hit our breakpoint. Let's look at the thread's impersonation data. And it's a pointer. It's not 0, which means we are running an impersonating thread. But let's say we don't want to break in every case. We want to just print out some information and keep running. So there is a way to do that. After the address, we add another set of quotes with whatever command we want to run, and G to keep running. Now, this command now can be a dx command. So let's print for each thread its client security. So cur_thread dot kernel object dot client security. And it is printing the client security for every case where the breakpoint is hit, which is awesome, but still doesn't give us all the information we might want on the thread. For example, we might want to get the thread ID or the process name. And we can't do that with the anonymous types that we just saw. So instead of printing client security, we'll declare a new anonymous type with thread ID being cur_thread.id and process name being current process.name. Yeah, we get the thread ID. We can also run this with formatting to get the thread ID in decimal. Seems like TI worker some threading TI worker is writing into a lot of files. Does make sense. We want a bit more information here. And we do want this information, the thread ID and the process name, but we also want some information from the impersonating thread. Specifically, which account it's impersonating to. Is it impersonating local service or network service or system? We get that by looking at the authentication ID inside a token. Let's just break. Okay. A second, let's just break here. So we have our current thread, client security. Inside client security, we have an impersonation token, which is actually the token of the thread, of the process it's impersonating. Now, it's not aligned. A token has to be aligned, which means we just need to zero out this bottom nibble. Like client security impersonation token. And we do and not 0xf, which is my lazy way of zeroing out the bottom nibble. And this is a pointer to a token. Now I can actually see this as a token, not as a pointer. But right now, this is just a void pointer. Yeah, that's the official Microsoft type. This is a void pointer. So Winback doesn't know how to parse that. But to know how to parse this token, we need to cast it. And casting with DS is very similar to ccasts. We open braces, empty token. This is a pointer to a token. We need to wrap these two for precedence. And now this is actually parsed as a token. Yeah, see that? This is very similar to ccasts. And like in a language, we have operation precedence, so we need to wrap all of this in braces. So we do the end before we do the cast. So inside that token, we have authentication ID. Now this is a pointer, so like you can see, we need to do an arrow. Sometimes the tab completion breaks. And inside that, we actually only want to see the low part. So we've got that. Now we can take this and add it to the structure that we're printing every time the breakpoint is hit. So we're adding to our type, authentication ID is the structure. Right, we added back. Oh, we need to add back the part because we want to keep running. So you'll see we see a few more processes writing into files here. We can see who they're impersonating. This is actually a hard-coded list, so you can go and look up which user account means which number. And the last part we might want to see here is it could be interesting to know what file the thread tried to write into. How can we know that? We are setting a breakpoint on empty write file. So empty write file is receiving as its first parameter a handle to the file it's about to write into. First parameter is saved in RCX in the register. And when we have a handle, we can actually use the handle array that we saw earlier that each process has to find the file that this handle is for and get its name. So again, we'll break once instead of running. Now we see RCX looks like a handle. Let's do. That's the handle array. And in that, we want to find RCX as the index. Yep, that's a file. And to find its file name, we need to go to object, that's the object header, and underline object, which points us to the object itself, which in our case is a file object. Now, because this is a file object, it has a file name. Well, someone is writing into Windows Defender, into the Windows Defender database. I'm going to guess that the Windows Defender on my VM started running again and is doing scan. So I can take this and add another thing to our type. So we add our last member of the type, file name, which is the current process, which we search the handle array to get the file name. And now we can keep running. And my debugger session died. I wonder why it does that. But it died just in time because this is the last command for this talk. And we can actually see for each case, thread ID, you can see the name of the process, the authentication ID telling us which user it's impersonating and which file it's writing into. Now, some of these don't look exactly like files, look like, sometimes we see pipes here, lots of stuff. And yeah, that is the Windows Defender process writing into the Windows Defender database. Now, this is just my example. You can use any kind of fields you want. And with DX, you can even write all of this output into a file on your host machine, which we don't really have time to show, but it's a really awesome capability. And this is just the tip of the things that you can do with this debugger data model. There's a million very useful things you can do. I recently published two blog posts about it. Other people published blog posts too. You can also use JavaScript to script things here and do even more useful things. And actually, this is pretty well documented. There's MSDN documentation, and every command is documented. If you run a command with -v, it will show you the inline documentation for it. And as I said, it's tab completed. And if you run, let's see if I can show it. Okay, we got Debugger back. We do dx cur process dot nothing, and I just click tab. It will show me all the different options here, all the different attributes that this has. And if I do debugger dot something, it will show me all the different options. This actually hosts all the capabilities. We have settings, we have utility. Yeah, under debugger utility control, we can see execute command that lets us run a legacy command, like a legacy extension. We can see the different breakpoint options with the documentation, what they receive, what they do. So go investigate that for yourself, find the scripts that are useful for you. I have a GitHub with some useful scripts. I'm also going to upload everything we did here over there. So yeah, take a look, do stuff your own, and stop using MASM, please.
Yeah. Can you still hear me?
Yep.
Oh, cool. Yeah, because you turn off your webcam. You can keep it on actually if you want for the Q&A.
Oh yeah, sorry, I didn't know we had Q&A. Yeah, if there's any questions.
Oh yeah, that's the best part actually, because we get some questions in the chat and stuff.
Awesome. Yeah, I had no idea how this worked. So yep. Any questions? I'm here.
Yeah, so regarding the question. So there's one question in the chat, and while we are at it, if you guys have any more questions, don't hesitate to ask your questions. So the first question we have is from Maxim. He's asking how to display all the lines without putting the dx-c100 argument in WDBG, for example, to display modules. What's the -c argument, by the way? Is it count or?
Yeah, -c is count. For example, if we do first session dot processes, it doesn't show us everything. There's dots here, and yeah, we can do -c100 to see the rest, basically.
Otherwise, what's the default limitation?
The default limitation is, I think, 64. I can't remember exactly.
Oh, I see what you mean. So it's easy to think that's
hex, I think. Yeah, this is a number in hex. How do we think? Yes, if you do command, comma, number, this is the results you want to see. And then we can do comma 10, and we'll only see the first 10 processes. Comma 100 will show us 100 processes. And if you want to use an exact number of exactly how many you have, you can do processes.count and use that as a number, or comma. I think that should work. Nope, that doesn't work. You'll need to just type the number. It tells you.
Or save it as a variable, I guess. Probably you need to save it into a variable and then reference it. And
yeah, that's probably true. Sometimes these things work, sometimes they don't.
Yeah, well, actually, I'm quite impressed you did the full-on live. That's, like all those comments, every time I need to Google them, like even when I wrote like script, I totally forgot what I wrote about. Like I used it like once, like for like the process history thing. I was like, oh, that's kind of nice actually. And then there's something I was not able to do. I forgot what. I was like, okay, I'm just gonna try to write it in C, and the C like I mean the COM interface is still a bit behind. I don't think they made any improvement yet, but I'm not sure. I didn't check it.
Yeah, that was actually the reason I wrote it.
But I was saying, like you said, like the JavaScript one is pretty good.
Yeah, that was actually the reason I wrote the blog post, because I kept forgetting syntax, like specific syntax. So I just wanted to have it all down in one place.
Yeah, that's definitely a good idea. And thanks for, I guess on behalf of the community, for writing those two blog posts. They're pretty good. You guys should definitely check it out. There is more example in it. How many words you say? Like you were quite proud of it. Was it like 8,000 words?
Yeah.
See, that's what happened when you hang out too much with Alex. You start counting in the number of words.
Oh yeah.
Cool. Well, thanks again.
That and calling it twin bag. That's the other side effect.
Oh yeah, definitely. Yeah. Cool. Well, thanks again for your presentation, and hope to see you soon.
Thanks for inviting me.
No problem.
The future is watching. Welcome to OPCODE Virtual Summit.
And we are back while our next speakers are getting ready. So you guys can already put your webcam on and all those things. Share the screen, etc. So I hope you guys enjoyed that presentation. I wanted to try something quite different, to have a technical presentation as a keynote. So you can like I was saying before, you can show up with your blog post, or even even if you have a blog post, you can just do it live and give a full-on workshop on it. So that's pretty cool. If quick reminder, guys, so if you're on Twitter, you can use the hashtag that you should see in the corner, which is OPCODE 2020. You're more than welcome to come on the Discord And also, don't forget to subscribe, so at least you get the notification for like all the live stream we are doing every 2 weeks. And for Windows Debugger, we're just discussing about it with Jaziel in the chat. There's a trick actually. With Windows Debugger Preview, they make you use the Microsoft Store. Even though the pop-up comes in like asking you to log in, you don't need to. You can just like click on the cross and you can just like install it without logging in. Without further ado, we're gonna get ready for our next presentation.
The future is watching. Welcome to OPCODE Virtual Summit.
Okay. Just remember to give control to my screen to Silvio. I can do this. Okay, I can do this. Okay.
Hey, thank you, Matt. Thanks for hosting us in OPCODE. Hi, everybody. Thanks for showing up. That is our first experience as speaker on a full virtual event. We hope everything will work smooth, but the crash is just beyond the edge. In this presentation, we will show our deep analysis on APT Linux backdoor, that for us is not so common, hoping that will help other researching that will find something similar and add to deal with. So let's introduce ourselves. My name is Silvio Laporta. I work as a senior architect in Leonardo Cybersecurity Research Center. Leonardo is an Italian multinational company specialized in aerospace and defense and security. It is the 8th largest defense contractor in the world. The company is organized in divisions such as helicopter, aircraft, aerostructures, electronics, and cybersecurity. One of our duty is to design advanced detection system for customers. For this reason, we continue to study complex attacks. Previously, I worked in Dell EMC as a security researcher and for Symantec as a malware reverse engineer. I hold a PhD in network security. So, Antonio, take the floor.
Hi, everybody. This is Antonio. I'm working for Leonardo Cybersecurity Division 2 as a senior architect. I've been an academic researcher for a while, and then I moved to more technical stuff, working as a cyber threat analyst for various customers. I just want to remember that this is a joint work with our colleague, Nino Verde, which work with us in our group.
Okay, so let's go ahead. What we are doing here, we basically on April, during our hunting activity, we find a couple of samples of a Linux backdoor that trigger our interest with really few detection, between 10 and 20 at a time. We started to analyze it and we found that there are some reports talking about something similar to it. This sample seems to belong to Turla, which is one of the most advanced APT in the world that has been operational since 2004, I think. It is really famous for developing a new and very advanced technique to avoid detection to ensure persistence on the network. The most famous is the Epic Turla, where they use the satellite channel to connect the C2 with the malwares. Turla is known for targeting, among the others, government, defense, Ministry of Foreign Affairs, educational sector, and all around the globe. Our story really started a long time ago. It is a story of a well-engineered backdoor, I think, that in the time had not changed so much. So the first report talking about it is from Kaspersky. It is from 2014. Mr. Kostin and Kurt are the authors of it. It talks about a Linux passive backdoor, which use pickup filter to intercept the traffic. After, on 2016, come out from Cert Milani, the RUAG report, which is a complete picture of the Turla threat actor activity, and it has some reference to a Linux backdoor, which also has some remote file system capability. And that is our Penguin as well. On 2017, for the security summit analyst, Kostin with Thomas and Kwan described maybe the oldest and longest cybersecurity operation in which take apart our Penguin as well. And last but not least, at the end of the 2017, Quan, yes, there is always a Quan story beyond, give on Twitter a Christmas Turla present talking about a new version with a Chrome binary embed. The Chrome binary is really important to construct the timeline. It is the legitimate Chrome binary. Antonio will talk more later. In those reports are described what we call Penguin 86 and Penguin 2. In our report that came out at the beginning of May, we found we will describe the new sample that we called we named it the Penguin 64. That is the star of this presentation. Come out, Penguin. It's here. So go ahead. So the agenda is really dense. We have limited time. We will try to stay in. Indeed, Antonio will show now how to build a timeline for the Penguin sample. After, I will describe the Penguin commonalities and difference, showing the main commands and features. Following, we will show how to build a magic packet, and we will conclude with a couple of demos. So let's go on.
Okay, with such a complex threat landscape, the first problem that we had was to place our sample in a timeline. One thing to remember is that we are looking at ELF files which do not have a specific compile timestamp that can be used as a starting point for the analysis, as it happened, for instance, for Windows executable. And since we are not a world-class Linux investigator, we proceeded with a trial and error process. Our starting hypothesis was that some of our samples were more recent than the one documented by Kaspersky in 2014, mainly due to the first seen date on VirusTotal. So to verify this hypothesis, we went through three different approaches: ABI version, statically linked libraries, and embedded binary analysis. So let's start with the ABI version, which is related with the kernel version. It is stored as an ELF note within the .note ABI tag field. This information can be extracted with tools such as PreDelf if you know where to look, or you can use even Python libraries such as PyElf tool to parse ELF sections. The table in the slides shows the ABI information for all Penguin version. As you can see, the most recent one is the 64-bit version. So we tried to answer to the question when binaries with such ABI were being built in the past. And we looked at several GCC releases, and we went back up to 2006, here when GCC 346 was released. We were still far from the version of the Penguin, since the ABI in that case was 2.6, and we needed 2.4 at least. But one thing became clear at that point is we could not expect a fine-grained information from such analysis, since the ABI seems to remain quite stable across the years. It remains stable for a couple of years at least. However, we decided to look at the Linux kernel version release date directly, and we got very old time references that were pointing us to the early 2000 period, which I have to remember is 20 years from now. And just to make sure that you guys get how far in time we are, this is the console from the Space Shuttle of 2000 compared with the console of SpaceX of 2020. And you can see that a lot of improvement has been done in 20 years. But also, to be even more clear, here is the Gladiator from 2000 compared with the Gladiator from 2020, which it's definitely a lot of time, you know. Okay. After we become aware of this, we decided to take a different approach. We tried with the version of the embedded static libraries, and this point lasts to our more recent period. Indeed, if we focus on the OpenSSL version, we find that the Penguin 64 bits embed the OpenSSL 101, which was released in 2014. And 2014 is also the year of the Kaspersky report. So this smells like the Turla guys decided to make a retooling during that year. And also, they probably were forced to update even the compiler to statically link the new OpenSSL version. This could be one possible reason why we see an updated ABI, but this is just an hypothesis. The last approach can only be used with the 64-bit versions because it is based on the embedded Chrome binaries that Silvio described before. We found 3 different versions of the 64-bit Penguin, and each version was embedding a different cron binaries. So our observation here was that since they were all clean and legitimate binaries, they had to belong to a specific Linux distribution. Another possible hypothesis, of course, could be that the threat actor built this tool by himself. However, we were lucky since we were able to find these builds inside 2 different distributions that are CentOS and Ubuntu. And during this analysis, we learned that a different release of a given Linux distribution may actually embed the same build of the binary utils, such as cron. That's why we can only detect a time range that, once again, is more recent than the one that we found with OpenSSL, since one of the cron was pointing us at up to 2017. And this was the best estimation that we were able to do with the information in our hands.
So just comparing the 3 versions of Penguin, the code is basically the same. The size of the code is really bigger. We are talking about 1.5 megabyte for the Penguin 64, and between 600 and 800 kilobytes for the first 2 versions. The size of the code is so big because the tool embedded, compiled statically different libraries inside the Penguins, such as OpenSSL, libc6, and the pickup filter as well. So what are the differences of the 3 versions? The 3 versions has more or less the same code, slightly different for the last version where they try to hide some strings and remove some, I think, signature on it. The first version, the Penguin 86, is a passive backdoor, so it just wait for an activation packet that comes from the network to start this activity. It needs 2 parameters from command line to work properly, that are the ID and the interface where to listening. I will talk more about the ID later. And it uses a command function to process the CPU that received the data. So the Penguin 2 is active. It is more classical backdoor. It has a hard-coded IP at the end of the file that during the init phase will be extracted, and it will start to beaconing to the CPU. And it also uses the same command function to process the data received from the CPU. It is the only Penguin that does not require the root privileges, because it does not use a root folder for its activity. The last version that is our star, the Penguin 64, is passive as the first one, but it has encoded the ID interface parameter directly on the sample, which is 29 for the ID and the interface ATH0, for example. It drop and run cron, and after remove the file from the file system in the root folder as .sys file. And it uses a different function as main that we call the callback. One other stuff to say is that the Penguin 2 is some of the sample of Penguin 2 are not stripped, so we can extract the name of the function that the attacker give in the code. So let's give a look to the code, and what we have is, for example, there is an happy string. That is, our Penguin are really happy. This string in the old Penguin is just hard-coded and put inside the function of upload and download. In the new Penguin, they are stacked strings. So the attacker changed it maybe to remove a signature, a string signature on the sample. Another important stuff, another example could be the ID code. So this code is used to process the ID that in the old Penguin is given from the command line, and this number will be used to calculate the first part of the network pickup filter used to validate the packet. So if you give to the old Penguin the value that is hard-coded on the new Penguin, that is 29, as I said, it will generate the same part of the filter. So as you can see from the code is do exactly the same stuff. Just it is maybe they're rearranged for compilation and the new architecture version. So go ahead and give a look to the command function that is the main function used for the first two version of the Penguin. This function is put inside a loop that is used to process the data received from C2. One of the parameters that this function needs to work is the CMD tab data structure, which is a table that has a column with strings and another column with colored with functions, and the 30 column is contain the number of minimum and maximum parameter allowed. So how does it work? Basically, the function will the malware will extract from the net from what is receiving from the C2 a string, and if the string match one of the string present on the first column, it will execute the corresponding function, double checking that the minimum and the maximum number of parameters are exactly the one specified in the last column. So the reference to this function in the first two versions of the Penguin are 3. On the new version became 2 because the 64 it is removed from the main. Okay. So give a look to the inside the command function. I say that what I already described is the try built-in function. It gets the CMT tab structure and execute the corresponding command. If the string does not match any of the string of the table, it will consider it as a shell command, and it will execute it directly through the bin.sh, giving storing the output in another file. So going instead to the do callback function, this function is not present on the Penguin 2.0. So because probably it wasn't the time to put there. It is present, but in the oldest Penguin and the new Penguin. As you can see, the function is more or less the same. They changed the name where the file used. So this function, what does is after the sample receive the activation packet, he expects that the CTO send back a file to him that it will save it as .session file inside the root folder. After save the file, the malware will change the directory and go to the root directory, and will call another function that we named UU decode. When we started to reverse this function, we thought that it was a new encoding schema that the Turla guys created for this sample particularly. But looking at the code structure, looking the difference between the code of the malware and this part of the code, we just started to think that should be something else. And we try to find some reference online or something similar. And digging, we find this utility that is called UU encode. It is one of the utility present in the oldest Linux version, which was used to transmit a binary file over a medium that does not support anything else than hash. It supports basically a two encode schema, that is the UU encoding and the base64 encoding. So looking at the code, another assumption that we made is about the next file, that is the hsperf data for the new version. So, and what we thought is that the UU encode create a sort of archive, and inside the archive, the malware expect that the file extracted from the archive, it is called the hsperf data, and this file should have the correct execution flag inside. After that, the .session file, the UU encoded file, will be removed, so it will be deleted from the disk, and will be executed the new file extracted from that. The output will be saved in a storage string. So That is the callback function. As I said, all the symbol has the same code base. So all the symbol has all the version of Penguin has all the same functionality and capability. On the left side of the slide, we have all the classical canonical backdoor functionality, such as download, upload, remote execution, and so on. On the left side, we have some particular functions that are used to manage a remote file system. These functions start all with do_vs. And this function works all at the same way. So for example, giving the vs start function, the operator sends to the Penguin after the connection is established, this command passing a target IP. The Penguin will extract this target IP and establish a new connection to the peer, passing directly the code of the command, in this case 15 in hexadecimal, and the target IP will reply with the information necessary to complete correctly the command. In this case, the file system type and the free disk space. The Penguin will close this connection and send back to the operator a string, a wrapped string with this information inside, such as WES file system type and the free space, available space. And it will close the communication with the peer and waiting for the next command from the operator. Okay.
Okay. Now we are ready to introduce the activation packet. So let's start with the scenario. We have an operator controlling two hosts directly that are host A and host B. Host B is listening for incoming connection on port XYZ. Then we have the Penguin Linux box, which is in a passive state still. In order to activate the Penguin, host A sends a specific packet to the Penguin saying, "Hey Penguin, please connect to host B on port XYZ. This is the packet signature." The Linux kernel reply with a reset or an ICMP message depending on the transport protocol of the incoming packet. But since this is not a normal packet, but this is a magic packet, the Penguin, which is looking for the incoming traffic, needs to sniff the packet, verify the signature, and follow the instructions specified in the payload, and establish a TCP connection to host B on port XYZ, and then the communication starts. So in order to make the Penguin happy, you have to craft a packet that respects some rules. The first rule is the pickup rule. The magic packet can be any TCP or UDP packet that match the filter represented in the slide. This filter is encrypted and statically embedded within the sample. For UDP packet, the filter means that the second D word of the payload must match the filter. That is starting at offset 12, the next 4 byte masked with E007 FFFF must be equal to 6005 BDBD. For the TCP packet, the filter is checked against the ACK number since it starts at offset 8. And that's it. Just we have to add a different version of Penguin, have different constant values. For instance, for the 32-bit, we have the BEBE instead of BDBD as a mask. The second rule is more a rule set and is a bit more tricky than the first one. I have to say that it was a real pain actually to understand. There are several bit masks that are applied to the first and the second D word of the incoming data. So in detail, the schema can be represented with data on top and condition at the bottom. The input to the transform function are the two D words represented here and the source port of the packet. Due to the pickup rule, some bit of the second D word have fixed values, while other, which are the ones that are masked by the pickup filter, can get arbitrary values. The transformation combines inputs bit to derive the final destination IP as represented in the slide. So we have 24 bit coming from the first D word directly, 4 bits that are grabbed from the second D word, and the final 4 bits that are taken from the source port and placed at predefined position. However, in order to create a well-formed packet, there are other conditions, several conditions that must be met, as represented in the bottom of the slide. Pieces of input data are combined in a Boolean expression. Colors let you easily see how each piece of the input is used in the condition checks. If the expression is satisfied, then you are almost good to go, since there is one more thing that you have to take care, but we will see it in a moment. One thing to note here is that most of the bit transformation does not align to byte boundaries, and this could have been done on purpose just to slow down the analysis. Another thing is that the 16-bit value coming from the concatenation of N3 with N6 is used as the destination port for the new connection. That is what I'm saying, will be always a TCP connection, regardless if the packet activation is sent via UDP or TCP. So there is this last thing you have to consider, which is the internal status flag of the Penguin. Indeed, you have two possible activation packets. Even if this is a 2-bit value, which potentially allows 4 different states, we were able only to get 2 values that are 0 or 2. When the Penguin started, its status is 0. Whenever the Penguin receives a well-formed packet, it toggles its state and performs the required action. Okay, but now on, it will ignore packets with the same status flag. So if you send again the same packet, it will not trigger any action. Okay, this is the setup for the demo. Host A gets IP.1, the Penguin gets IP.130, and the host B get IP128. Host B is listening to 2 different ports. Since we are testing both UDP and TCP packets and both the status flag, 0 and 2. Okay, this is the demo setup. On the top left, we have Penguin x64, which is a virtual machine that we are infecting. On the right, there is a packet sniffer, Wireshark. On the bottom left, we have the host B, which is listening to the 2 different ports, and then we are host A ready to send packet on the bottom right. So we just started the Penguin here. We are just verifying that everything is okay. We can see that there are 2 processes running because one of the 2 is the legitimate cron binary. Now we are ready to send packet. We send the first packet. We can see that we sent an UDP packet and received an ECMP destination reachable message from the Linux kernel, but immediately after there is a TCP connection triggering towards the host B on the expected port. Now we send the TCP test packets. Again, we can see that we receive a reset in this case according to the protocol definition, and we verify that everything is working okay because we have 4 processes running, and we know that there is 1 process for each connection. We keep going here. We send other packets, and we see that the Penguin is replying to us as expected. Again, we keep going. We send the last packet on UDP. We get a new scene back, and we verify that now we have 6 processes running as expected because we just triggered 6 different connections. And now, if we close the connection, we just will go back to the virtual machine. And we verify that we got back to the initial condition as expected because we have just 2 processes running. Okay. But we went a bit farther okay, we here have the same setup. So we run again, we infect the machine. We verify that everything is okay. Okay. Then here we have host B ready to accept connection. Okay, then we send the probe and we get a X calculator inside the Penguin virtual machine. which is working smoothly. You can do all fancy stuff that you can do with calculator. And if you look at the PS3, looking for Penguin, you can see that actually there is an HS perf data running, which has been executed by an SH from the Penguin XS64 binary process. Sorry.
So we did that just to verify that our hypothesis on the UU encode and the final file was correct, and seems that we had the right. So that concludes our presentation. If there are any questions, we are open.
Thanks for the presentation, guys. It was pretty good. While we're waiting for the chat to get ready for some more questions. So just I want to give a small reminder, like don't forget to send me your slides after so I can purge them on the GitHub. I was just talking with Yarden about it now. I dropped the link in our chat. So far, yeah. So there's Jeremy on the chat saying great presentation, guys.
Thank you.
Thank you.
And let's check if there's any question. I don't think there is. There's two good comments. People saying well played. Great. I guess you explained everything so well that there is no questions. That's I think. Yeah, that's pretty much it. Well, cool. I guess. I guess that. That closes it if there is no question. So that was pretty cool. So when did you guys started to analyze that malware?
It was at the beginning of April. We had just a sample, and our analysis take a couple of weeks, basically, more or less.
Oh wow! So it was very recently, huh? Okay, that's pretty cool.
Yeah. The first sample that triggered our hunting activity was for the end of April.
And the report got published, what, like a week ago now, I think?
It was published middle of May.
Okay, yeah, that's cool. So we have one question from the chat from Jeremy. Over what channel protocol is the file upload download occurring? HTTPS? Question mark.
The file upload download are they established the diffierman secure channel using diffierman, and after it was established a symmetric key that is used with Bluefish.
Okay, cool. Sounds good. Well, thanks again, guys. And looking forward getting a copy of the slides so I can reread it
Absolutely.
after.
Absolutely. Thank you very much.
Thanks again.
Thank you. Thank you.
So while we're getting ready for our next discussion panel, just making sure everything is working well here on my side. So like I was saying, the slides are going to be available on the GitHub as usual. So that's always a given for that. And then that's pretty much it for the slides. And if you have any questions, do not hesitate. And like now we're gonna have a conversation with Joseph Menn, who you probably, like I was saying at the beginning, you probably have heard of him, or if you didn't, you definitely read his articles because he has been publishing a lot of stuff for the past, I guess, 20 plus years, and that should be I'm gonna ask him right after, but I think it has been like 30 years or so, something crazy. So you definitely read his articles, and actually, funny enough, I think once I was in the plane, because in the flight sometimes they show you the headlines of articles. So I think one of the article that I saw was from him. So I was like, oh, that's pretty cool, when you end up checking the article of people you actually know. But yeah, so transition, and then we're gonna start.
The future is watching. Welcome to Opcode Virtual Summit.
And yeah, we are live. Hey Joe, how are you doing?
I'm great. How you doing, man?
Yeah, pretty good. Thanks again for joining us. Definitely looking forward to it. We were discussing the other day, so there is an update for your book, right?
Yeah. So the paperback came out yesterday, which I'm excited about. It's updated a bit, and it looks cool. I don't know if you got I'm on video here, but this is what it looks like. It's got the old amber color scheme, the old monitors.
Wasn't it green before?
Yeah. Also,
because I found a PNG of your book, you're next to you speaking, there is a copy of the book. It's green, the one you just saw is orange. I was like, oh, interesting. Is it for the different version?
yeah.
Oh,
Yep.
cool.
They always like to make it a little bit different. And its content's updated a little bit. Beto's no longer running for president, and there's obviously been some other events in the past year.
Yeah, I guess the question now is if the election are going to be cancelled or not. At this point, we don't know. No, I guess. But tell us a bit more about your book for people who are not familiar with it. What are you basically covering in it, and
Sure.
why it's also kind of cool to have some history of hackers over the past I guess decades, because how long have you been a journalist or reporter for now?
So I've been a journalist for 30 years, but the last 20 have been 20 and a little bit, 21, 22 have been on tech. And I started covering security pretty much from the beginning. So there are not a lot of reporters that have even covered Silicon Valley for that long. Certainly not security. There are a couple of us. But my last book was kind of a downer. It was called Fatal System Error, and it was about how governments are aligning with organized crime, and the attack surface keeps getting bigger, and basically cybersecurity is hopeless. Even though there was a happy narrative arc in that was the underlying point. And since then, there have been lots of other books that have been depressing about other aspects of security being terrible. And I wanted to do something more positive to sort of keep people who are in the game, keep doing good stuff on security, to keep them motivated and maybe inspired, and for people who are new to the profession, to give them ideas about which shoulders they want to stand on, what decisions, sort of collective sentiment by the hacker community have been made before, and why, so you don't have to reinvent the wheel. And so the book is called the Cult of the Dead Cow: How the Original Hacking Supergroup Might Just Save the World. And it's about the oldest surviving and most influential U.S. hacking group. It's still around today, and it was founded in 1984. So one way or another, they've touched all the major inflection points in security and privacy over the last 3 decades.
It's funny you say still surviving. It's true, because a lot of the groups also disappeared. I forgot the title of was it the Fall and Rise of Sean Fanning, when it was about the Napster thing?
The Napster book, yeah.
If we're talking about the old school hackers, I guess that's one name that comes up to my. Actually, I think that's how we met originally, back in San Francisco.
Right. So my first solo book was about Napster, and one of the revelations in that book that the people didn't realize, despite how famous Napster was, is that Sean Fanning was a hacker, and he was actually in another great old school group that is still around, not quite as old as CDC, called Woo Woo. So I think you're familiar with that. So right, and so I got to know, when I was writing that book almost 20 years ago, I got to know some of those people, and I sort of stayed in touch over the years, and that sort of got me more and more alarmed about the state of security. And then I sort of went back to them for the happy stories, or the really cool things that the hacking community have done, including, coordinated disclosure, really great defensive companies that work for the government on offense and defense. The DARPA's fast track grants for cyber, and a lot of activism stuff. So the CDC were most famous, the Dead Cow were most famous 20 years ago when they released Backorifice and other hacking tools that shamed Microsoft into taking security more seriously. But they also invented hacktivism, which is in the news again this week with Anonymous, or people branding themselves as Anonymous, taking credit for some of the anti-police stuff in the US.
Yeah, definitely. So actually, like the anonymous story, I didn't really follow. They just I saw they posted a tweet. People were kind of not going crazy over it, but like it got a lot of momentum. But like I don't think they released anything or anything in particular, right? They just took advantage.
No,
of
so
the
I mean, it's
news,
it's sort of classic Anonymous, coyote trickster stuff. It's part marketing and part activism and part bullshit and part hacking. So I have a story out last night at Reuters, which is my day job, about the sort of the resurgence of Anonymous. I mean, I guess the biggest success is they got to be trending on Twitter, at least in the US, for 2 days. The word Anonymous was trending, the hashtag. So they claimed credit for a denial of service attack that temporarily knocked the Minneapolis Police Department website offline. They claimed credit for other stuff, which they didn't really do. They were circulating some old passwords from Minneapolis city officials, which had, were in Troy Hunt's Have I Been Pwned site for a while before that. So that was bogus. But there's some bot activity going on that pumped up the mentions and so forth. There's like millions of new followers, new accounts, that's clearly automated, and like a ton of retweets. And like some of the old school Anonymous accounts suddenly have these new followers. I'm like, we don't know what's going on. But there's another thing they did for some reason. Like, this is because it's the internet. K-pop fans, there are all these sites. There are these accounts that are very active on Twitter, some of which are automated, some of which are not, that are devoted to Korean pop music. And they started retweeting a bunch of Anonymous and Black Lives Matter stuff. And they actually did one thing, which is tangible, which is that the Dallas Police Department was saying, "Hey, please send us videos show us videos of illegal activity around protests, looking for looters, riots, whatever." And they basically organized a human DDoS, where they said, "Hey, everybody," these Korean accounts that had been supporting Anonymous and BLM said, "Hey, send them music videos or whatever." And so they overwhelmed this Dallas official app, and they the app went offline for a while. So something is happening. There hasn't been any serious hacking yet. I've just reported within the last 10 minutes or so that the FBI is looking into the Minneapolis DDoS, but it's a DDoS.
Yeah, it's not really like there's a compromise or anything. Also, like the K-pop thing was connected to the Anonymous in some way. Because I saw some tweets about it today. Like people were talking about one of the hashtags that from the BLM that got whitewash, and then they're like, "Oh, like every time I open that one, I just see a bunch of like K-pop artists." It's like, so that's related because like it's kind of hard to follow what's going on now.
Yeah.
So I have like these filters. Like, is there any compromise or not? No. Okay. Like next year.
Well, so I'll say one thing. I mean, I cover, in the book, I talk about the sort of the evolution of hacktivism, and so of course I do talk about Anonymous. But there are advantages that the old school groups like the Cult of the Dead Cow have that Anonymous does not have. So Anonymous has been infiltrated basically from the beginning by police informants, by foreign government agents, and by organized criminals. And so it gets really messy really fast, and it's sort of hard to organize. This time, as far as I know, they're not even using IRC and sort of other sort of organizing tools, so it's all out in the open. Or most of it
probably
is so
using
far.
Discord like us, actually.
Yeah, well, they're not yet, as far as I know. There's no Discord. But CDC was a much smaller group. Is a much smaller group, much more cohesive, and they could sort of establish principles and stick to them. And they really worked hard at figuring out what the right ethical call is on a whole variety of issues. Whereas anonymous, anybody can say they're an anonymous, and they are, and anybody can declare an op, and it's an anonymous op, and you can join or not. So it's you lose a lot when it's all diffuse like that.
Yeah, how many members was the CDC?
So about 50 since the beginning, about 20 active at any one time. And one of the cool things about it is that it's still run by one guy. So with their permission, I outed all of the core members who'd never been identified before. So among the more famous members that people already had heard about, Mudge Zatko and Chris Rue were both in the Loft as well, the great Boston, shared hacking space. The guys testified before Congress in '98, and they founded. Chris Rue founded Veracode, a really important now unicorn static analysis company. Mudge went on to DARPA, Google, and is doing other really cool things now. Analyzing code for like sort of safety. So they've done all these cool things, but Mudge had been outed previously. Chris Rue had been outed previously. I sort of outed the others with their permission. And one of them is the founder of the group, who'd never been named before, was Kevin Wheeler, really nice guy, lives in New York. He came up with it, when he was like a young teenager, and he's still in charge now. He's kind of a recluse. And then like the famous one, the one that got me all the media, was that Beto O'Rourke had been one of the earliest members, when he was like 14, 15. But back then it was about text files, sort of edgy text files. It was before, the group kept evolving through, they were like funny and sort of, teenage before they were famous hackers. And so it kept being new blood coming in and old blood going out.
Yeah, I guess it was like the equivalent of like Instagram material back then, but it would be like the text files with like the e-signs and everything. Actually, even like it had been a while, but there was some e-sign that did some comeback. I don't know if you remember like the ZFO e-sign. Like they did like they hacked some famous hackers. Like I would say like. Actually, maybe it's a while. I would say it's between like 5 and 10 years, the last issue. But a lot of those things died. And yeah, same thing with IRC. When it was like still used, at least to like share content, it was easier. Last time we were talking about it with Grok, the problem now is like a lot of those old material is kind of like lost over time. And for instance, like if you look at the Congress speech when the CDC members were like presenting, a lot of the points that they were raising are still relevant today. And the problem is a lot of people like always come up with like similar points later on, not knowing that it had been covered like 10 or 20 years ago. So there's a big failure on the collective on like properly like archiving and documenting like such things, to continue some more.
There's too much material and it's not organized very well, and everybody's sort of always attracted to the shiny new thing. And I don't think people should be forced to go back and read 20 years worth of Usenet. But that was one of the purposes of the book. I mean, it's actually a fairly short book, and I was just trying to like hit the high points with a coherent narrative thread, so you know what's been done before. That was a big part of this, and particular sort of like the ethical issues and the sort of and politics, because despite the fact it was a small group, it was actually fairly reasonably diverse in some ways. I mean, they came from different backgrounds, they're interested in different things. Some folks hated the U.S. government, some folks worked for the U.S. government, and it was cool to get like their old chat logs and see where they disagreed with each other and how they came out, because people are not really comfortable talking about their personal ethical decisions, because you're sort of holding yourself up to be criticized or knocked, and it takes some guts to talk about this. Alex Stamos does this. He gave a talk actually before Snowden about at either Black Hat or DEF CON about professionals having sort of an ethical responsibility, in cybersecurity to over backdoors and things like that. And then later he went to Facebook and walked the walk.
Well, especially when your views can evolve over time, like that's one of the things. Like you were saying, a lot of them were still teenagers. It's a bit like that story of that guy who wrote like the anarchist cookbook, and later on he had like to apologize for it, saying, "Well, I was like, I think it was like 17 or something. It was like I didn't really like know what I was like talking about," and he realized it's just like following him all his life.
Well, yeah. So that's another thing. Another reason I like writing about these guys is that in talking to a lot of really old school hackers, I mean, before the widespread internet, before like 94, 95, it was I would say it was pretty amoral then, because it was small stakes. And then as like suddenly everybody's online and like your grandmother is at risk, the people the people who stayed with cybersecurity kind of leveled up in terms of morality. They're like, oh, wait a minute, this is kind of fun, but I actually know some shit, and I've got a responsibility to help people. And maybe I'm going to do that in the government, maybe not. Maybe I'm going to do it in the private sector. Maybe I'll do it in my own time. But the people who stayed in, by and large, developed like more, they put more work into developing their own ethical code. And a lot of like new people now who are just coming in. I mean, now it's a respectable profession, so you can go to a nice college and work for a nice company and do cybery things, but not really examine like the moral significance of what you're doing, and that can actually lead to bad things. So in a way, like ironically, the people who grew up breaking the law really, put some time into thinking about what they would do and what they wouldn't do, and you might well disagree with where they came down, but they actually put some effort into it, and that's not done enough anymore. So I think people should make up their own minds, and this might help them talking about this stuff, reading about this stuff.
Yeah. Speaking of ethics, with what's going on now with like the COVID and the Black Lives Matters movement, have you seen anything like, or is anything had been published like in the news like lately, saying that law enforcement is using like contact tracing to like actually like follow protesters or things like that, or not yet?
Right. So there are a lot of interesting things going on, and some of the people involved in it, either were in CDC or learned at the feet of CDC. They're like they're the granddaddies of a lot of this stuff. But some of them are involved with Apple and Google now. Like, so there are very senior security people at Apple and Google who worked for At Stake, which is this great security boutique from 15, 20 years ago that was started by Mudge and Chris Rue and others from the Loft and CDC. And Apple and Google were under immense pressure as COVID, spread, from governments to help with contact tracing, to in particular to have Bluetooth be running all the time, and to fork over personal identifying information about people in case they tested positive. And Apple and Google worked together and said, no, we're going to leave it in the hands of the user. We're not going to be turned into spying devices. We're going to let the user raise their hand to see if they've, confirm that they've been tested positive, and to notify people. And it's going to be based on, who is in proximity if the app was running, rather than, the actual phone number, the IMEI and so forth. So it's like they're keeping it away from the government. Some governments are pissed, but mostly they're falling into line. So in Europe, the UK is still fighting. France and Germany are still fighting, but others that were saying no, we're going to make our own app or whatever. They can't really do it without Apple and Google playing ball, or it's going to be much harder to just use the telcos.
But Apple did release an update 2 weeks ago, no? Because I remember like 2 weeks ago, like we're like something having the live stream on the Wednesday, and we're having talking about mobile tracking, and then Sima from the chat actually sent me a link of like that new update that was happening at the same time. I think Google did it around the same time. So have we seen any like stories of abuse yet? Like since there's like some protests like going on now, or because if I understood correctly, they can be like only one official like application per country, and it has to come from the government. So we haven't seen any like type of abuse on that point, right? Because so the users still have some sort of control on it, right?
That's right. So far,
okay.
it is in the OS now, and so it's good. It's early days, and this isn't black and white. I mean, it may be way less effective. Some governments are saying like we're not going to be able to. Not enough people are going to opt in. It won't be effective. Yada yada. So we'll see. But a lot of people are watching it, and the civil liberties groups, by and large, while not crazy in particular about Google's practices, also faulting Apple in some ways, are pretty happy about this. So if you're rooting for civil liberties positions, then you should be supporting what these guys are doing.
Mm. And same thing, still on the same topic. A few weeks ago, you wrote an article about NSO. Can you give us some? And then I think a bunch of your colleagues actually wrote a bunch of stories also on the same topic in that movement. So what's going on with the FBI investigation? Also, because also a lot of them pivoted into like COVID trackers, right?
Yeah.
So, which is a bit ironic.
Really
there's like this lawsuit, and then we're like, "Oh, we're gonna help you for like your healthcare,"
Yeah, no, it's really interesting. So a lot of my colleagues, me, others at other publications have been doing a lot of work on NSO, and it's really interesting. It's like when there's something like COVID, like all these like surveillance companies are saying, "Hey, we can really help protect public health," and then when it's protesters in the streets being terrified about overreaching government surveillance, like those companies don't want to talk at all. They won't return any phone calls. Like, no, we don't know anything about that. It's the same guys. So yeah, my colleagues wrote. I wrote that the FBI is investigating NSO. That's still ongoing. I don't have anything significant new to say about that, except that NSO is also, it was reported elsewhere, trying to get into U.S. police departments, saying, "Hey, we're a terrific tool." So that could be a little awkward. My colleagues at Reuters wrote that NSO, among other like really pretty military type contractors, were using COVID to pitch their value to all kinds of folks all over the world. We got some of the pitch letters and brochures, and it's the stuff is double-edged, and unfortunately, because a lot of what's going on is classified, it needs leakers sometimes to reveal what's going on. But stuff that can hacking tools can be used for offense or defense, and the same is true of surveillance stuff. I think most of the people that I've known for decades on this are not big fans of surveillance for any purpose. And the only way to make sure it's not being used for ill is to not let it be used at all. And so that tends to be where they come down.
Yeah, I mean, I still find it crazy that it's a foreign government selling like surveillance tools to like the US government, like I think that's kind of like the irony of it, And then there is a lawsuit in parallel, and obviously, they probably have some good backup, because they were they like asking about like to have like immunity or something at some point in the lawsuit, like to have like if they were like a nation state. There was like this story where like, oh, we're gonna claim like sovereign immunity, and they were like, well, listen, you guys are not a government entity,
So yes, so there's a bunch of different lawsuits in addition to the investigation. So there's some in Israel against NSO, and there's some in the US, and in some of them they say, yeah, well, everything was cleared by the Israeli government, so therefore go away. Anything we do for the government is cool. But the problem is that in other suits, private suits, they're saying, well, if we sold to some government in Africa, it's up to them how to use it. and there are, but in other cases, it appears that they're pretty hands-on. So that's one of the big issues, and one of the problems with getting in litigation in multiple venues is making, if you wind up making contradictory arguments, that can lead to real trouble. So I think that's what the antis, the foes of NSO are hoping happens.
Yeah, I mean, because in terms of like foreign interference, I think that's pretty strong, well, Africa, I guess it's like poorly regulated, so like it probably won't get much visibility, especially like in East and West Africa. But the fact, like they still sell to like the US government, and there is no local alternative, if it was like a Russian product, the story will be like completely different. People will start going like even more crazy, like for some reason, like it's not that much.
Sorry about the dog.
Is he barking every time someone say anything about NSO?
No barking. Sorry. Different days working from home.
Yeah, that's fine. But yeah, because in terms of like, and you say there is how many lawsuits are like going on in the US? No, is it only like the single one for like the FBI investigation with Facebook, or is there more to it?
Against NSO?
How
many suits? So
because to be honest, the one in Israel don't really count, because like it's like they're gonna get cleared anyway. But like in the US, like there is only one, right? Because it's kind of hard to follow those differences.
So it was really so the big one was filed by WhatsApp, owned by Facebook, and hasn't happened before. I mean, there's never been a major company suing, a hacking company for breaching U.S. law. So that's very interesting, because Facebook can afford some lawyers. So one of the issues there is, was there U.S. infrastructure involved? They have to establish, I think, that, I am not a lawyer, but I think they have to establish that there were U.S. servers or infrastructure that were involved, and that NSO was either doing it or knew it was happening, sort of conspiring. So even if it was a foreign government that actually had the hands on the keyboards, if NSO was coordinating it, or they were using NSO infrastructure to do it, that looks to me like a violation of U.S. hacking laws, the same way that the U.S. indicted members of the Chinese PLA for breaching U.S. steel. The laws apply. So I think that is the most significant case. We'll see where it goes.
Actually, if anything, I'm kind of surprised that like Apple didn't join the lawsuit, because at the end of the day, like a lot of the exploits were like targeting like also iOS. And they're known to be like quite aggressive with companies in general. Like they sued like Corlium for doing a virtually like a virtualizer for like mobile phones for copyright infringement or something like that. So it's kind of like surprising they don't actually like sue actual like companies like NSO, just like Facebook did.
I think they're being quietly supportive. I mean, you don't need. I mean, it's a lot to take on, and I think there's kind of a divide and conquer thing. Apple's dealing with Corellium, and I think that's less. I think that has some support, but it's less obvious, and they're happy to let Facebook take the lead on this one. I mean, WhatsApp got hacked, so I mean, there was an O-Day in WhatsApp, so.
Yeah. I mean, the Corlium story was kind of weird also from Apple. Like they tried to acquire them, then they sue them. It's like.
I think that's a very interesting case.
Especially like from a security standpoint, like you probably remember like 20 years ago, like every time, or even was it at Black Hat? Like there's a guy who was publishing like some Cisco exploit, and then like he had to be defended by EFF, and it was one of the first major cases where like well, you're like you cannot afford like a lawyer, and then you can get like some actual legal defense, because at least in the case of NSO, they would definitely be able to afford like legal defense. It goes even like beyond that, but yeah, but like you said, like they probably give some like silent support to like the Facebook thing. It will not be surprising.
Yeah. The Cisco case, at where the guy was, arrested at, or they tried to stop his talk anyway at Black Hat. These things also happen every few years, and every 5 years or so, and people don't remember that this has happened before. But it will keep happening. It'll probably happen more. Particularly as there's more nation state stuff, there's more big money stuff. Even if the precedents are fairly clear, if nothing else, it buys you time to try to suppress something. I think eventually the information gets out. But I'm happy that people are much more aware of these dynamics. I mean, when I was writing before Snowden about the 0-day market and the government role in dominating the 0-day market, the official U.S. policy was that they wouldn't even admit that they bought O-day. And now it's out there, and they talk about the equities and balancing the stuff and the White House process, and maybe that's not entirely accurate what they put out, but at least people are talking about it. They understand the issues now, so
yeah,
knowledge increases. That's good.
But but in that case, has to still be like the O-day market. Like also a lot of stories were just like security researchers are like, oh, I found this cool stuff, I want to talk about it, I want you guys to fix it, then you like do get sued. Fortunately, that does not happen as much as before, but yeah, at some point it was a bit brutal. So we're approaching to the end. I know you have to run for another call after. There is we're getting some questions from the chat. There is one question from Abiodun asking in these, I guess, to go back to the first part of our conversation, these days of COVID, where we are more inclined to leverage the internet, what is the danger of hacker groups? Is there still like any like hacker groups that are like as dangerous as before, or is it more like nation state, I guess?
Right. So, I mean, this is back to, unfortunately, the everything's getting worse general frame, which is still true. So, I mean, there are lots of kinds of hacker groups. I mean, CDC is basically the good guys. There are other good guy groups. The bad guy groups are much more serious now. As I sort of went into in my previous book, Fatal System Error, the bad guys do capitalism better than the good guys do. It's hard to know how much to spend on defense and what to spend, where to spend it. Whereas the bad guys know immediately what works and they reinvest in it. They're also diversify. So you can have one guy running the botnet and farming it out to others, after he's harvested what he wants to. Somebody else is writing exploits. They differentiate, and they're super good at it. And because they're doing it with almost impunity in many countries, even in the US, the odds of getting arrested are way under 1% for illegal hacking. There's no reason why they're not going to get bigger and better. In the meantime, the attack surface is bigger, gets more complicated, and it's really bad. So there was some hope that COVID was bad enough that the major ransomware groups would stay away from hospitals, and some of them actually said that they would, and that has not been the case. Ransomware attacks are way up. It is blurry what's nation state and what's just money. And then, of course, in some cases, you have nation states that need the money. So North Korea comes to mind. So they're fine with ransomware. It is much worse. And one of the nice things about the good guy hackers is that they have formed volunteer groups to help defend healthcare orgs. So there's at least two. There's one kind of run by Sophos, and there's another one called the COVID-19 Cyber Threat Intelligence League, which has 4 leaders. One of them is an Israeli. I forget the other two. And one of them is Mark Rogers, DEF CON head of security.
There's two Microsoft people actually part of those four. The disinformation part is pretty active also, especially at the moment.
Yes.
We had Sarah Jen who spoke here a few weeks ago.
Yeah, disinformation is really scary right now.
Yeah,
and it's much harder to combat than straight up hacking, and straight up hacking isn't easy to combat. And then you have all the nation state complications, and within nation states, you've got people politicizing frickin' everything, not just information, but whether it's a good idea to wear a mask or not. So, we're in, dark times. The thing that I want to call out that makes hackers really useful, really great, and more important now than ever before on the good guy front is that by definition, they're critical thinkers. You're looking at a system and trying to make it do stuff it wasn't supposed to, it wasn't intended to do. These guys and the other and the people that have come after them also have one or more moral cause, and they're adaptable. So when the circumstances change, they change too. They learn to get involved in politics, or they learn to, navigate like Wall Street, all the stuff that they didn't have any practice doing in the beginning. So, so can you, so can everybody. And we have like a major worldwide shortage of critical thinkers. And hackers already have a head start in that, so they should be held up as examples of what can be done that's positive.
Good. Before you leave us, any last words?
No, keep passing on the knowledge, yo. There's both technical and sort of philosophical. I think it's one of the cool things about the old school hackers is that it was pretty interdisciplinary back in the day. I mean, people were interested in hardware and software and all this other stuff, and they'd sort of collaborate. And these guys learned to deal with the media and politics too. I think that's important, and it's harder because the field is so big now. People specialize, so branch out a little bit. Read what other people are doing, and talk about the political and ethical issues.
Cool. Actually, we got one quick question from the chat. Is there any upcoming project of a next book?
So it takes me a long time to do a book. I churn them out like once every 8 years or so. Cult of the Dead Cow just came out in paperback, and my job now is getting people to read it. I'm not, I have no other books on the horizon. My day job is doing investigative cybersecurity stories for Reuters. I like that, and maybe something will come up out of that makes me want to do another book. But I have no plans. Thanks. Appreciate it. I'll let you know. I'll be back when I got another one.
So, sounds good. Well, thanks again for joining us. It was a pleasure to have you, and also to get kind of a bit of a debrief on what was going on lately. It's getting really hard to follow the news now. I don't know if you guys do it. But
all right.
Cool. Well, talk to you soon, I guess. Thanks again.
Thanks, Matt. Thanks, everybody. Bye-bye.
Take care. And we're back for our last presentation for Matt about the Intel PT. So looking forward that one. So while we're getting ready, just a quick reminder. So if you guys want to access the slides, we're gonna push them on the actual usual GitHub, and the talk is gonna be available after because it's live anyway. So we can always go back and watch it, and we're gonna cut it in different segments, so you can just look at your talk of interest. If you are missing the chats and stuff, don't hesitate to join the Discord server. So that's kind of like the new IRC. Initially, I did create an IRC server for the first two editions, but I guess people don't know to use an IRC client anymore. It's also not the most convenient way of doing things. But yeah, and don't forget to subscribe also. It does help to get notifications when there is anything new. And yeah, I guess that's pretty much it. So we're gonna get ready for the next presentation in a few minutes.
The future is watching. Welcome to OPCODE Virtual Summit.
Yeah. Okay. So this is I don't know how this thing works actually. This is kind of new era for the security conferences, right? So let's see how it works actually. So can you see my screen? Yeah, so this is about just using Intel PT for general vulnerability analysis or exploit analysis, or maybe possibly security researches in general. So I work for Darren Green. It's a new company, just one-person company right now. So maybe I can introduce because many people doesn't know me, I think. Actually, I'm the author of Darren Green patch dipping tools maybe 10 years ago. So after I joined Microsoft 10 years ago as a security researcher, actually, there were some legal bindings that I can't work on the open source project at the time. Now it's very loose, but at the time it was a very strict because it was the previous CEO, and he hated open source, right? But now I'm out of Microsoft and I'm just trying to revive the framework as a more of data science kit that you can work, right? You can use Jupyter notebooks to load binary data, and maybe you can perform some statistical analysis. It's still work in progress. And as I said, I worked for Microsoft for 10 years. And I worked as a defender, but now I look into both sides. The NSO groups you talked about, all these groups, the 0 days, whenever the 0 day comes out, then MSRC and our team actually work together to find how the exploit mechanisms, how they are bypassing, those things, to research those things. So currently I'm just starter. So it's really early phase. I'm just looking around different technologies and how I can use them for possibly security product or maybe threat analysis, right? So Intel PT is one of those technologies. So what is Intel PT? So it's a processor trace actually, right? So the feature is supported by the processor from the hardware, and the documentation actually says it is supported from Broadwell, actually, Intel Broadwell CPUs, but practically it only works after Skylake CPUs. And all those tools and anything that are available, they only work on Skylake. But most Skylake, I don't know, it was 2017, I guess. I don't know exact timeline when Skylake was available. It was 4 or 5 years ago. So most of your computers might have these features embedded already. So what you can do with Intel PT? So basically you can trace code execution in instruction level. Technically, they only trace control flow changes, but combining with the instruction images, actually you can reconstruct full instructions. So you can use triggering or filtering by CPLs. Maybe you can just trace kernel code executions, or maybe you can just trace process images. CR3, maybe if it accesses some memory pages, maybe then you can access it, right? Or you can filter by IP ranges. Maybe you want to just monitor some code executions inside some modules, for example, right? Those things are possible. So it's very strong. And if you know how to use this technology, it will help you very well with multiple different jobs in security field, actually. So it's not just for example, the AFL fudging, right? So they are trying to use, they made the AFL fudger using Intel PT as a kind of feedback loop for the code coverage, right? But it's very slow. So you will know why it's very slow. I don't know if there is any improvement these days, but last time I checked, it was very slow. So the intended usage is actually post-mortem analysis of crashes or some performance issues. You want to actually collect these traces, and you can check where is all the CPUs are used for code executions, and you can just fix it, right? And when some program crashes, actually you can enrich the code stack information using this Intel PT. So this presentation is not actually, I don't want to go really deep into the Intel PT. I will just go overview of this technology. But with this presentation, we want to explore the practical, right? So practical, again, not about writing papers or those things, academia researches, but more of how we can really use it for daily basis jobs, right? So that is the focus of this talk. So using Intel PT on Windows, I spent a lot of time just figuring this out, actually. So because originally the Windows Intel PT tool, it was released by the Cisco Talos guys, actually, right? So one of those guys is actually working for Microsoft now. He made this tool. Actually, it does every single small configuration for Intel PT, actually, right? So it's from scratch. It's a driver. But it only works for Windows 10 pre-RS6 because after Windows 10 RS6, Microsoft introduced IPT.sys. As the name suggests, actually, it's the driver for IPT collection, right? So this driver actually checks whether there is another session actually going on. And if it detects Windows Intel PT or any kernel driver that actually accesses some specific MSR area, then it will actually blue screen the system. So you can't use Windows Intel PT for Windows 10 post RS6. But conveniently, Alexei Ionescu actually made this WinIPT tool that is wraps around this interface for IPT.sys, and you can just conveniently use that. So it's really easy. So the other option is actually using Intel debug extension. It's a Win debugger extension, right? So you have you need actually two machines, two physical machines. One machine you actually launch Win debugger with this extension installed, and the other machine is the target machine with kernel debugging enabled and USB kernel debugging enabled, and you need special USB cable for those work. It's, I don't know, $16 or $20 somewhere, Newegg or maybe Amazon, they sell it. And you connect it actually using the remote kernel debugging session. Actually, you can initiate these Intel PT sessions. So for Linux, there are a lot of information. Actually, you can just go to this link and you can find a lot of good informations. Actually, the real challenge comes when you try to decode this Intel PT log, actually, right? So for analysis of this recorded package, actually, you can use libIPT library. It's a multi-platform library from Intel. It is basically a very standard library that can expand this Intel PT traces into human readable, maybe instructions or dump code. So mainly you will use two tools, ptdump and ptexd. Ptdump is just dumping the raw data from the binary trace log. It's not like exe, ptxed actually. Xed is the disassembler from Intel. So ptxed is actually disassemble actual instructions from Intel PT trace log. So for this decoding purposes, actually, because the Intel PT only logs control flow changes, so it only logs the actual addresses, bunch of addresses using different packets. So it doesn't save actual instruction bytes. So you need to have that instruction sources somewhere. From this diagram, for example, ptxed uses ptdump, the trace log as a source for the control flow change, and PE or ELF files as a kind of raw instruction byte sources, right? And you can take the actual raw instruction bytes from process dump. The only problem is that PTXED doesn't understand the PE or process dump. It understands ELF, I guess. But, usually I do some researches on Windows platform. PTXED doesn't understand the PE. The only way is based upon this PT dump. It shows them some address informations, right? So extracting that address informations from these executables or process dumps, you need to manually extract those instruction bytes because it's a raw instruction byte without any headers, nothing, just raw instruction byte. PTXD takes some inputs as those files, raw instruction byte files, and they can reconstruct free instruction based upon that. So for practical purposes, just you will just spend the whole day just figuring out which memory area you want to take out for this PTXD tool. So I don't think you can use it for any practical purposes. So maybe you can just investigate whether the process dump, the PT dump is correct, or it has some information you might want, right? So there is another challenge is like because Intel PT relies on these static instruction bytes. For example, if you think about G code execution, so just think about Edge or Chrome browser, they use a lot of G memory area, right? They just run JavaScript code as a assembly code, just compile and run, and the area is garbage collected. It will be gone. Then there is no point, you know, whether the memory area is actually the instructions that actually the Intel PT logged or not. So that is one challenge. The other challenge is shellcode. Shellcode actually very similar to JIT actually, but it's just static code, right? It's not compiled, but it just lives on the memory and goes away. So these two of them are challenges and possibly limitations with Intel PT technology, but yeah, somebody will figure it out how we can do that. But for now, we just want to focus on some static memory images and how we can figure out how we can just analyze some control flow changes we are interested in. To understand or use Intel PT actually, so because Intel PT is very uses a lot of compressed recording, actually you want to understand how they are compressing these records, and it will help you very well with further analysis because it will give you a lot of hints about those control flow changes. So one barrier in utilizing Intel PT is just compressed format. And you need to decompress. You need to use libIPT, I said. For example, there is a branches, right? So similar to LBR. So I don't know if you are old school, you remember LBR. So somebody actually from the reverse engineering community, someone actually tried to use LBR to reconstruct a full code coverage, I remember. But Intel PT is more powerful actually. So when CPU encounters any branch instructions, jump, JE, call, read, any instructions that makes these branches, right? Then it will record the actions. And it uses T or NT 1-bit information for these jumps and no jumps, actually, right? It just recorded in very, very compressed format. I will talk about those packages later. So indirect calls and jumps, so there's no way you can just use a very small compressor format. You just record the full thing. Sometimes it just compress it. Maybe if it is 64-bit address space, maybe you can just record 32-bit based upon whether it's your near jump or far jump, right? So unconditional branches, just like jumps or maybe calls to some static predetermined memory addresses, then actually you don't need to record it because from the instruction byte, you can figure it out, right? Those things are just gone. Intel PT logs will not have that information. And this will make a lot of confusions actually when you try to understand the Intel PT logs. So IP compression itself, whenever it logs some instruction pointer logs, actually upper parts are missed whenever some overlap happens with some previous records, actually. So to save those space. So to record all these things, they use package, right? Package are just package. And there are a lot of different packages, but PSB is some kind of boundaries, because if you log a lot of information, maybe some data in the middle may be corrupted. I don't know, maybe sometimes hardware error or something, but you don't want to throw away whole thing, right? PSB, just make it packet boundaries. So any information inside that boundary, they're just valid as itself. You can just take them, then they will make sense itself, right? So that is PSB. Actually, through this presentation, we will call it sync offset, right? PSB locations, we will refer it as sync offset because libIPT code actually use sync offset pointing to PSB locations. So it's very convenient just using sync offset as this term for PSB locations. TAB is target IP. Whenever you call something for indirect jumps, indirect calls, you need to log whole thing, right? So in that case, it's a TIP, target IP. TNT is whatever you take jumps or not taking jumps. So compression overview. So based upon this PSB, TIP, TNT, TIP, TNT, it just repeats. And based upon this data, actually you can reconstruct full instructions. So if you look at some trace logs, actually, here is a snippet of IPT logs. Actually, I can share a full thing later. But if you look at this, this is output from, actually the original PT dump is binary, right? So using PT dump, you can make it as text format so that we can understand what is happening. Of that 1C, it has a PSB. It has a lot of pad bytes, but it means that from here, actually, we can make sense of these IPT logs. Add offset 3 dB, for example, for this log, it says tip PGE. So there is a PG packet. It means the instruction pointer is located at the location indicated by the packet, which is 0007. Yeah, it's a very familiar address space, right? So 3470. So we are starting from there. So this packet is logging something starting from here. So this location, right, from this packet, tip PGE, is here. So I extracted this from IDA. You can extract it from process dump too. So you can see that all these instructions are just doing some stack operations, maybe GS60, maybe shellcode, I don't know. Then it just goes and calls some static address. And it has TPGE indicated from this location. The next call is very interesting, right? Because this call is just a static location inside the binary. So from the packet, it doesn't log anything about this call. So the execution actually will continue to the target address of this call. And if you use PTXCD, it will actually decode everything here. So it doesn't know it doesn't care about the boundaries of these calls or anything. It just follows these instructions. So for indirect calls, somehow you can just decode the full thing. There is no instruction that are interesting, but here 63332 location equals some RAX location. If we are just human, you can just figure out, oh, RAX is coming from here. So you can just know that, oh, this is the location, right? But whatever these tools, they need some information, control flow change information. And it just logs the lower bytes. So it's for FB70. FB70, it's calling there. CS location. I don't know, there is some address discrepancies here, but address is 3332. Yeah, maybe this is for other one. So 33 TIP just designates some indirect codes, and you know that the target is 4FB70. And decoding continues, 70 just goes, and now you have JNG, so it's branches, and you need to figure out it took the branch or not. That is coded as TNT. So dot dot, I figured out this is not taking it didn't take two conditional jumps. Actually, this is typo. I have some typos here. But next, it will encounter read instructions at FB94. Then we might know from this just statically analyzing this assembly, we know that where it will return. But this thing doesn't know where it will return. So the process trace will record the location of the return address, right? Return address is basically indirect jump. So decoding continues and so on, right? So this thing is, this is how it works actually. So actually I can show you. Yeah, I can share later actually. So the only challenge we have, some challenges we have is that if you decode full instruction bytes for example, if you run Office program, for example, 10 seconds, it will generate 1.4 or 1.5, for example, right? For 1.4, 1.5 size of process trace, for example, because it just dumps the ring buffer, full ring buffer memory that is designated from the command. Then out of those, the actual the recording is only, I don't know, a few hundred megabytes. But if you try to expand full instructions out of it, it will become, I don't know, actually I couldn't expand everything for just 10 seconds of Office trace because the output is too big for every single instructions. Possibly it will be a few hundred gigabytes. And if you use libIPT tool, actually I couldn't finish it because when I run it on my machine, I have a server machine at home. I waited, I don't know, 16 hours to decode a 10-second amount of IPT log because I wanted some full logs for the process space because you don't know whenever some exploit works, you never know where the actual exploit will jump to. And I wanted that full logs, right? So just a few hundred megabytes of actual Intel PT data expanded to a few hundred gigabytes, possibly data, and just decoding takes possibly more than a day. So it's not really practical. So I figured out the decoding process is very slow because libIPT just uses single CPU because it's just simple operation. So you are supposed to build your tools upon this libIPT because it's just library. So IPT analyzer is just Python wrapper around libIPT. I just expose very, very essential methods out from libIPTs. I just built my own class out of these libIPT functions, and I just exposed some of those methods. Maybe you can expand it later for your purposes. But basically what it does is just doing the operations we did, the decoding operations in parallel. This is possible because all these packet boundaries are kind of independent. So if you run multiple processes using this libIPT or IPT analyzer code upon this separate PSB boundaries, right? Packet boundaries, then you can actually process them separately, then reconstruct them later as a one single code execution path. So that is the idea. And it took a few days just to build the tool. Basically, I can show you the code. Basically, what it does is just exposing very simple interface, right? Just open the libipt, you get the sync offset, and you can add image base, because when you want to decode some instruction byte, the IP locations, you actually need that actual instruction byte images. So you can add it, and you can actually decode some instructions at some point. You can actually decode it by block segment or something. And actually you can get some information from the IPT file too. The actual interface, Python interface, is in PyIPT. So this is the wrapper, right? So it has one instruction class. The first is just IPT, some general class. The next one is instructions, blocks, and error codes, right? So it's just three simple classes, right? You want to work on some blocks. Block means page blocks, right? Blocks or instructions from IPT log. So you can open some IPT log using IPT class. You can locate some code blocks you are interested in, and actually you can dump actual instructions from those blocks. So that is the idea that I had. So based upon this interface wrapped around the Python, you can actually build different tools. And these are some example tools that I built. For example, you want to enumerate every function calls from these IPT logs. Using libipt, it's almost impossible to use, I don't know, full day maybe. But using this tool, it uses a WinDebugger tool, which uses PyKDE to actually load WinDebugger process dump. So the idea is that whenever you take interpt dump, at the end of the session or in the middle, maybe you can take multiple dumps. You take process dump and you just save it somewhere. Later, you just combine this interpt trace with this process dump. And IPT analyzer will understand this WinDebugger process dump, right? So then it will just automatically extract the memory locations that are loaded inside the interpt. So very simple idea, and it saves a lot of time for you. So block analyzer, you just, the thing is that it's just reading caches, right? So it doesn't, these tools doesn't read interpt log directly because it's kind of just flat files, and then you never know where is the locations that you are interested in. So before that, actually, you need to generate a cache file. So this is the tool, cache.py. So it will just enumerate any, it will just decode the full interpt log, and it will enumerate, because a lot of security researches are based upon the block start locations, function start, some jump, the location where jump is pointing to. So we just cache those locations. I can show you later, but usually those cache is from out of 1.4 gigabytes interpt log, 300 megabytes meaningful the packet data. The block cache is around 500 megabytes actually. Using this block cache, you can locate the locations that you are interested in very easily. So this one, find API call. So for example, you want to find, for example, kernel 32 create file. So you pass it as an argument here. Then it will load the process dump. Then it will enumerate some modules, and it will resolve the symbol, and it will extract the exact memory address for kernel 32 create file. Then it will just enumerate the blocks, right? Then we want to, CR3 is 0, but default is 0, but it don't, we are not actually just processing this right now, but address, based upon this address location, then you can actually find the actual PSB location that actually contains that crate file codes, right? So everything is processed by this PSB blocks. Then from this PSB block, we do further analysis, and we can actually enumerate each instructions that are calling this crate file. So that is the idea. And here is one case study. Actually, I shared it through the blog post. This is one of the easiest and can be complicated example, because this is what is that? Office equation editor vulnerability from 2017. But there were a lot of variants found later, and Microsoft actually removed the binary. The thing is that this is Stack Overflow from very old legacy component from Office. But the thing is that the exploit technique is using actually returning some location. It's not ROP, but it's using some ROP-like technique. So from bug triage or vulnerability analysis point of view, it's not really easy to figure out what is happening there, right? Because you want some accurate information when that control flow changes. So that's why I chose this example. So I used WinIPT to just take the dump. This is the example you can just acquire from some public sources, actually. IPT tool is a WinIPT tool that is included in the Alex Ionescu's GitHub repository. You can just pass process ID and log file name. So, for example, I launch Office exploit, and it will actually launch equation editor as a DCOM object, right? DCOM process. And I acquired the process ID and just pass it as an argument here. And output is EQ equation editor.pt, just name it. .pt is just process trace file. So it runs. The thing is that even though this tool is really cool, sometimes there might be some timing issues. There can be a lot of different issues. So maybe you might want to try multiple times. So, right? So sometimes it creates really awesome processor trace file that has full information. Sometimes, somehow, it misses something, right? It's not corrupt, but it misses some information that we need. We need it. So sometimes you get some partial dump. I don't know. I didn't root cause all these things, why it's happening. But you might want to try multiple times. If you look at the dump file and if you run pt dump or ptxed, you know that it's correct or not. So now you have the dump. You need to take process dump using proc dump, process explorer, then just take process dump from this process, equation editor.ex. Then you run IPT analyzer. Actually, the tool name is decode blocks. You just pass the processor trace dump file. And this is a memory dump file. It will generate the cache file. So cache file will expedite whole analysis later. So if you run this command, I have some old Geom machine at home. It has, I don't know, 32 core or something. So it's not super fast, it's not super slow, but it has a lot of cores, right? I ran it maybe 10 minutes, maybe 15 minutes. But the latest machines, if you have, I don't know, 16 cores, maximum maybe 10 minutes. Maybe if you have really slow machines, maybe, I don't know, maybe 30 minutes. But the block cache is just 500 megabytes anyway. So based upon that, like it's just running different Python processes using multi-processing component. So they are not just fully utilizing the CPUs, just 3%, because the Windows is just limiting the CPUs. It's whatever. Then for this vulnerability analysis, because this is just one case study, how you can apply this Intel PT technology, right? So equation editor, if you did any vulnerability analysis or exploit analysis, you know that whenever the control flows changes, it's a bad sign, right? We know that the vulnerability might be inside this equation editor, so we have some assumptions, and we want to know the memory address range for this module. So from the process dump, we know that it doesn't even use the ASLR because it's a legacy component. So start and this range, we know that some code executed inside this address range did something and it made some malicious code control flow changes. So we want to dump any blocks, basic blocks between this memory address ranges, right? So using dump blocks tool, you just provide process PT file. You provide memory dump as you did before, and you provide a cache file generated beforehand, right? Then you give this memory range 40000 to the end address, so SNE. Then dump blocks will generate full log of basic blocks. So it will not generate full instructions. So it just shows the basic block changes. So it just utilizes the sync offset things, right? Block cache file contains block address and matching sync offset. So it just goes through this block cache file, and you know where is the PSP package that is matching that. So now you know that whenever something happens, this is just some casual investigation, but you can make some automation based upon these patterns of exploits later, actually. So that is something that I want to do as a next step for this tool. So this is more of manual fashion. So your assumption is that the control flow change comes almost last phase to last instances of these basic blocks of this module. So this is the almost last part of these basic block changes. We know that maybe the return instruction here looks suspicious, right? If you don't find anything interesting from here, maybe you can try next blocks here. But this one might be interesting. Then you need to note the sync offset here. 2D236C is the actual offset from the process dump. Then using this sync offset, actually you can dump the detailed instruction around this basic block. Then you might encounter some interesting instructions there, right? So using dump instructions tool, you just pass process trace memory dump, and the uppercase S argument, you pass sync offset, right? You got this sync offset from previous investigation, this sync offset, right? So you're dumping some instructions from almost the end of control flow changes from equation editor module itself, because if something exploited, it will come from equation editor. It will do some vulnerable code execution, then it will just jump to some shellcode or something. That is the assumption. So we just E is and what is that? PSV packet log sync offset. So we don't want to dump full things, right? So we just want to dump some range of this what is that? This PSV block. Now, if you just dump that last locations, it's a very small file. Then you can it will dump the instructions, actual single instructions, every single instructions. You can identify here right? Instruction framework, equation editor frame, WinProc, some offsets, but maybe some buffer overflow happened just before here. So maybe you can do further investigation there. But the interesting point is here, right? So the end of this function call, it returns, but it returns again. Then it goes nowhere because this is a very legacy module. It doesn't use JIT or anything like that, but it just goes to some random memory location, the RWX memory location. If you investigate with the WinDebugger, you can see that it's RWX. Then it's running some code. That looks very suspicious. So we know that this is shellcode, right? So the return instructions actually this is more of, it's not RP, but this is some trampoline code that actually goes to the shellcode location. So this is that we now understand this exploit is using some return address trampolining to jumping into some shellcode. And we just pinpointed the actual vulnerable function, possibly, right? So probably this address, the function that has this address. So yeah, that is transient non-image address. I mean, this is what I said already, right? So, and next stage shellcode, you can even use this as some shellcode analysis tool too, because it will log full image of shellcode. For this case, the shellcode is still there, and our process dump had all these instructions there too. And jump RAX, and we can even pinpoint where the next stage shellcode is actually running, the decoded shellcode and everything. So dump instruction shows, maybe you can use multiple dump instruction command to do further investigations how this shellcode is actually running. So conclusions. So this is not really about groundbreaking research, but it's more about introducing the Intel PTs for the general, so that they can use IPT analogy is just a casual tool that I wrote for my own purposes, right? But there is the concept, if you can decode this process dump within some reasonable time, and you can cache some information, some important information as a separate file, you can actually use it as a very strong tool for various purposes. Just I shared vulnerability analysis as an example, but you can, there is no limit actually. You can detect rootkits, you can detect, I don't know, some embedded threats, or maybe you can detect some persistency mechanism on your machine. Yeah, you just take 10 seconds of Intel PT log for your full system, and you can analyze there is any anomalies there. Maybe you can detect something interesting, right? Some code executions that are not supposed to happen, maybe happening there. So this is a very promising technology, and that is my conclusion. And that's it.
That's pretty cool stuff, actually. Thanks again for speaking about it. While we're waiting for some questions from the chat. By the way, can you imagine during all this time I thought your name was really Matt O. Can you hear me? Are you on mute?
Oh yeah. So yeah.
I already thought your name was Matt during all those years.
Yeah, Matt is my name. Yeah, for your convenience.
And a quick question, actually. Do you know a company called Tetran?
Yeah. They have very.
Do they do something similar, or is it like something different?
Last time I checked, I think it's almost a year ago. They actually dissected what is it, the Windows kernel patch protection, right? So I think it's been a while, but I think they used emulation. But my memory might not correct. might be correct.
Yeah.
But I thought it's really cool that they used some technology, but I don't think they used Intel PT. But you can use the Intel PT for that purposes too, right?
And is there an equivalent like for ARM, or is it just like specific to like?
Yeah, I know ARM has similar mechanism, but I didn't use it. I'm not really familiar with ARM. I'm more a Windows person, even though Windows runs on ARM too. But yeah, had it before Windows. The Intel, I think I remember. But you need more research.
Yeah. Sam, I'm not very familiar with ARM and just started to get into it. I was like, I feel like I'm missing out.
Yeah, usually ARM has some more advanced stuff before Intel CPU, right? Usually because they can move quickly with new features.
Yes, I've been doing a lot of cool stuff, but same thing, like most of it would be like Linux based, so like I've always stayed away from it. Speaking of, there is Spender like from GRSec in the chat. He says thanks.
Yeah.
Yeah, that's pretty cool. So the tool is on GitHub. So you're using Alex library, right? The Win IPT underneath, which is using Windows driver underneath, right?
So the thing is that there are two phases. One is taking the dump. You can use any tools you want, right? There were three options that I gave you. One is the old Cisco Talos tool. If you really want to do some dumping from pre-RS6 machines, then there is one option. So after RS6, the tool says RS5, but after RS6, the tool is really working well. Win IPT, you can use Win IPT. It works really well. Just make sure you take multiple dumps and just compare those dumps, because sometimes it fails because it's not the tool itself, it's IPT.sys or maybe timing issues, right? The ultimate option is using Intel Debugger extension. Okay. The only problem is you need a physical debugging interface, and you need to invest $20 for the debugging cable. And making USB debugging, kernel debugging, working on your systems are really challenging. For someone, it takes days.
Yeah. And
honestly,
is it using like a serial port or something, or?
Excuse me, what was that?
Is it using a serial port for like the physical debugging, or?
USB 3.0.
Oh, okay.
So yeah, it's connecting to the remote machine. So I didn't dig deep, but Intel extension is sending some package. I don't know there is any open specification about that, but you can easily debug or reverse engineer this Intel PT extension to figure out what kind of package it is sending to the remote machine to enable this Intel PT logs. It will be interesting too. Yeah. Then you don't need to potentially use Win Debugger for that purpose, right? You can just build your own Python library that is sending same package sequences to the remote debugging machines to enable those features, I guess.
But there is an extension for Windows DBG.
So. Yeah. Okay, so you just need a Win Debugger, Intel extension. You can just download it from Intel website. It's free. You just install it. But it has a little bit of a glitch. It has some glitches. You need to patch the binary to circumvent something. I can share later.
Oh, you need to actually like patch the actual extension.
Yeah, but it's not really core function. But it checks something. But somebody asked that question 2 years ago. Nobody answered. And if you Google that problem, there is only one entry from the Google search result. And someone actually asked on the forum on the Intel. Nobody answered for 2 years. And I figured out it is some bug inside the Intel driver. But it's not the critical bug, but it's just some accessory check on the driver. Then you just patch it out and everything works perfectly. So I can share that later too.
I see. I see. Yeah, that's pretty. And is it because like Intel PT is not like widely used since it had been released, or come it was like leftover? Because from what I remember, when it got released, it was like something quite powerful for tracing. People were like, "It's like really cool." Like Richard Johnson was, I remember, was like really excited about it.
I have no idea actually. I have no idea why. Maybe someone is already using it a lot, right? But Intel PT, so I'm looking into different technologies, right? I used TTD at Microsoft even before it was public. I thought it was cool. Intel PT can be more powerful, right? But it doesn't save the context. That is a limitation. So it has a limitation, right? It doesn't save the CPU context. It doesn't save register values. Sometimes you can potentially lose instruction bytes if it is JIT or shellcode. So those things can limit the usage, but still, I think Intel PT is really powerful. And using these tool bases, then you can make it more, if you make it more easily accessible, then I think you can find a lot of application of this technology. I remember someone talked about UEFI tracing using Intel PT. Those things, right? Those things are really cool. So
yeah, especially for that would be quite cool actually for UEFI, because it's probably not as complex as Office. And I mean, if you trace like because like how big did you say like the cache file is now, or like a few gigabytes?
Cache file for what?
Office? The block cache file when you're like doing
for mine I can share. I don't know. I can share my screen. Right?
Yeah, you're still sharing it.
Yeah, you can see that.
Yeah.
I can hide the. Yeah. So this is full trace actually for IPT. There were some failures, right? So PT file. Yeah, this is the case, right? The PT file is just 11 megabytes. It doesn't make sense somehow. So normal PT file should be like this, 1.4 gigabytes. The other thing is that you remember that I talked about all this compressing, all these things, right?
Yeah.
But most of them are just 0.
Oh wow.
So so they used a lot of so because it's just a ring buffer, right? So but it makes sense. But
you could still compress it like before, right? I mean, I don't know.
Yeah, so if you compress, still it's just 3 megabytes. So look at this, right? So the PT file is not really big. So you just record full trace. It only takes 3 megabytes of your disk space for just Intel PT file. You need to take the process dump, right? Process dump file. I don't know where I saved it. Oh yeah, process
and
dump.
At which point are you taking the process dump? Like after you want to analyze something, or before to compare?
You can do both, right? You can do both, and you can compare that later. But for this case, you can just take you can actually attach debugger to equation editor and just hold it before it exits. Or you can use proc dump to take dump whenever some processes exit. So there are a lot of different techniques, right? I took it when the process exits. So it's 1.6 gigabytes, but you just compress it, just 44 megabytes. So 2 information sources, you just generate a block cache file. Then block cache is 500 megabytes. It's just, I didn't do any optimization. This is just Python, the structure, serialization structure. I don't remember the name, right? So it's just a loose file. I didn't do any compression, right? If you compress it, if you just split it, it's just 100 megabytes or something, right? Then using this information, you can do some analysis here. For example, I can share this. For example, this one. Find the API calls, then you just pass these things. For example, I was just suspicious, maybe it will be executing shall execute, right? because it's just showing some dialog boxes saying it failed to run something, or you can just search for these API calls, or maybe it's dropping some files. I want 3 cases. So find API calls, output for shellcode execute. Yeah, you can get actual location. There's just one instance, right? So it's very exciting that you know that, oh, this sync offset has this information. Maybe you can trace back from this location where this shellcode execution is coming, right? Even for URL download, I don't know, it was not there. Create file. You wanna enumerate every instances where the file is created, files are created, and you can dump. The only problem is that you don't know what is the file name, because file name is just short-lived and just goes away.
Yeah.
So that is the limitation, but still it is very powerful because it is full instruction dogs. Nothing is missing.
And it's tracking like each instruction, not only like the branch jumps, right?
Yeah, it's just expanding, right? So
okay,
process trace dump, original dump only records meaningful control flow changes. So that's why it's really small. Combining it with real images, process dump in this case, you can reconstruct full instructions for basic block changes, right?
Okay.
So that process, the converting process, takes long time. So this approach is like more like, let's look at the basic blocks first, because if you want to decode full instructions, it will take forever. But the meaningful changes, they usually happens by basic blocks, right?
Yeah.
We only caches basic block locations, that is 500 megabytes. So based upon those basic block locations, now I want to know where the shellcode execute happened. Then from the process memory dump, we know the exact location, right? Because it's there, right? So we just retrieve that memory address and searches for basic blocks, whether that memory location matches any cache locations. And that cache location has information to the actual PSB block inside interpt file, right? Now, from the interpt file, now we extract actual instructions. So it's more of a step-by-step approach from this full interpt file to basic blocks, functions. Then we go deep into the actual instruction levels. In that way, you don't need to dump full instructions, right? And you don't need to dealing with this huge instruction files. You just focus on the basic blocks.
Okay. And actually, I'm just checking your blog post now. There's a comment you didn't answer. I'm gonna read it for you. There is an MSR register, debugctl MSR, that can be used to track branch jumps. Is there a difference between this and Intel PT? Is Intel PT better?
Yeah. So the truth is that I'm not really expert in Intel CPU architecture. Right? There are better guys out there. But from my memory, actually from the reverse engineering community, I remember it was, I don't know, 10 years ago, 15 years ago. I think it was Pedram Amini. I remember that he tried to use those branch records to save something. But
so it's pretty old, though? That MSR is
really
pretty
old, I guess. There might be some technology in between the branch recording and something inside, something between. But now we have this Intel PT, and I don't know, maybe 90% of machines that you have right now might have these features enabled already. So you don't need any new investment if you have one machine. So the approach that I'm doing, because you need to run some malicious code on your system, right? So usually what I do is just use USB stick. You just install Windows image. So you can just search some information on internet. You can find how you can install Windows on your USB SSD card or something like that. It's, I don't know, $30. You just buy them, just install Windows to go there are public tools available, not from Microsoft. From Microsoft, you need a special USB thumb drive, right? Very expensive one. I don't know. I remember maybe $100 or something. But there are some public tools that convert your Windows image to USB thumb drive image, right? Then you just boot from your USB thumb drive. Now, potentially, maybe malware can damage your hard drive, but there are limited chances, right? So you just take a chance, and you can just run. Yeah, you can just run from the USB thumb drive. You just run whatever. If you are researching malware, just malwares. I don't know anything there. You take information, you collect all those information. You can just reuse your laptop after rebooting as your normal operating system. So you don't need any additional investment for this research, because people think that, oh, for this, because this is using hardware features, maybe I want to buy new laptops, maybe $1,000, $500. You don't need new investment. Just using your normal machines. If you don't run really super malicious stuff, I don't think it will install something to your hardware. So if it's reasonable, then you can just use it. Then if you are really serious, then you can just buy some machine, $500 machines or $1,000 machines, to run these things as just malicious box that you can run these things and collect things, analyze. There are a lot of possibilities, and I think there might be some security product you can build upon this technology too.
Yeah, I mean, even for sandboxing, that you would get something like much better than what you have now, I guess.
Yeah, the only problem is that you can't take out those dynamic memory contents. They are just gone. Yeah.
I see. Cool. Actually, one question from the chat: is it possible to get extra information about these extracted addresses? For instance, some vOPCDE protection rights, flags, and so on.
Can you repeat the question? I don't understand the question very well.
Oh, no worries. Is it possible to get some extra information about those extracted addresses? For instance,
no, it's just address. It's just,
okay.
There are, that there are, whether it is from CR0 or CR3, so that whether it's a kernel instructions or just user instructions. You can know that. There are a lot of packages that indicate whether this is coming from the privilege page or not. So you will know that it's kernel instructions or not.
Oh, because you have the control register, since you have the context also?
No. There are separate packages showing that, from now on, it's executing some userland instructions.
Oh, I see what you mean. Okay, interesting.
A bunch of different packages out there.
So you not get the actual Windows structure, but you get like the CPU information, which would contain like more or less something like more or less similar.
Yeah, I can. Let me see. I can show you. Yeah, this is the ptdump output.
Mm-hmm.
ptdump is the tool from libIPT. So if you run ptdump like this, just ptdump is just from libIPT, right? You just compile it and just run pt. I removed the MTC. This is timing information.
Mm-hmm.
Right? Pad is just padding. So this is ironical because they wanted to save the whatever this memory and trace log. They are go extreme as like a logging jump and non-jump as just 1 bit, and they leave a lot of padding bytes, and they just waste huge space.
Yeah.
So if you don't remove them, the ptdump file will be huge. So if I remove them, 1.4 gigabytes of dump is just mere 169 megabytes or something. So you can read it. PSB starts. This is, I think, timing information, but it's not really important for us. Those are for some performance tuning purposes or whatever those other purposes than security research, I guess. TMA, I guess, timing, CBR, I don't know, PSB, and so this is a PSB packet. Timing, a lot of timing informations, right? So mode exec, I don't remember what this is, but TPG, I remember there was some CR3, CR0 informations here. but yeah, I forgot a lot of things. TSX, exec. Yeah, I can find it here, but
yeah, it's okay. Don't worry.
Yeah. There is a instruction that shows whether this is from kernel or userland. Yeah, then
That's
from
cool.
there you figure out. Yeah, that is extra information. And as new CPUs are coming out, probably they're adding new packet formats, possibly. Yeah.
That's cool.
Yeah.
Well, there is no more questions from the chat.
Okay.
Thanks again for joining us and for your excellent presentation. Don't forget to send me the slides. I see. Can you even export them? Like I see you're like using like localhost for your presentation. Oh no, it's in HTML. Okay, yeah, that makes sense.
Oh, this one? Yeah, I can export as a PDF. This is
awesome.
Yes. So I will share it later, maybe today. And thank you for inviting me to this cool conference. I really like it.
Yeah, no worries. Thanks again for speaking and joining us. Well, I guess have a good day.
Yeah, you too. Bye.
Thank you. So that's it. That was our last presentation for today. We will see each other again in 2 weeks. So on the 17th of June, the slides for today will be available on GitHub as usual. So either today and tomorrow, and we're gonna like cut the presentations. Yeah, that's pretty much it for today. So if you have any questions, don't hesitate. If you have recommendation of speakers, don't hesitate to like drop names. Spender, if you want to come speak, you're welcome anytime. And so yeah, so if there is also a particular topic that you think we should be talking about, definitely let me know. And yeah, if there is anything you would like to see or like to change, like don't hesitate. Like the feedback is always welcome. And so for now, I think the format is gonna keep like every 2 weeks, you know. So just so whenever there is a cool blog post or something that will, you know, we'll just like can talk about it and cover it. Although I don't know, like actually, like let me know what you guys think. If I should just like split it in two and do it like once a week, you know, instead of doing like a block of like 3 hours, 3-4 hours, like every 2 weeks. I don't know what would be better. Because I find it like quite hard also like to kind of like let people know whenever there is a live. So that's why like subscribing like does help because you get notifications and stuff. But still, yeah, format wise, like I don't know if you have any comments or anything you would like to see to be different. And yeah, otherwise. Yeah, I guess that's pretty much it for today. Don't hesitate to come join us on the Slack channel. Jaziel is there with us. He's quite active, so it's good. Yeah, and if you are like us, you know, missing IRC, like Discord is definitely the best thing out there. It's much better than Slack. I don't know how many Slack you are, but I think I stopped counting at 10, and every time you need to create a new account, was like on Discord, you have one account and you can use it on few servers, which is like quite useful. So yeah, I guess that's pretty much it. I hope you enjoyed today's live stream, and yeah, don't forget that if you do want to access the actual call for paper, it's always available here, right? So you just go there, you can submit something, and yeah, otherwise you can even like ping me directly. But yeah, that's pretty much it. So definitely want to thank our speakers from today. So our keynote speaker, Yarden Sharif, and the two Italian penguin doctors, Silvio and Antonio. That was a good presentation. Joseph also for the chat. That was pretty cool. And yeah, thanks also to your dog. I kind of feel like we missed out on that one actually. Like you know, like we need more puppies in that show. You know, they're quite nice. And yeah, and Matt for your presentation about Intel PT. So everything's gonna be on the GitHub anyway, just like the previous edition. We'll do like a GitHub README file also, where that's gonna link also to like the blog posts that were already existing. And yeah, so yeah, thanks again everyone for listening. And if you have feedback, like seriously, do not hesitate. Just show up on the actual Discord. Drop me a message. If there is also like a side note, you know, if there is like people you know who are trying to get into like security or like, don't hesitate to tell them to join the Discord, you know, since there's a mix, you know, of like old school, new school people, you know. I think it's a great place like for people getting into the industry to ask questions, as you know, they may have like different questions. I know it's like such a big field compared to like 10-20 years ago. There's so many things to like learn or like cover. It's not always like obvious to know where to start and what's interesting. But yeah, that's pretty much it. So thanks again everyone for being here with us. And yeah, that's it.